Hey, everybody. So I don't know about you, but when I first learned about standard deviation, it seemed a little bit complicated and I didn't really understand what it meant. My textbook told me it was a measure of variability, and that still didn't help me very much. And so this little walkthrough here is how I sort of figured out what it meant, and hopefully it will help you too. Um, we can calculate the standard deviation very simply in Excel using the stdev function. I'll show you it. We just do equals stdev and then dot either p if we're finding the standard deviation for a population, or s if we're finding the standard deviation for a sample. So I'm going to do s because the data I have here represents the price of 10 new cars. Um, and I think there's probably more than 10 new cars in the world. So this doesn't represent the entire population of new cars, just a sample of 10 cars. Then I open a parenthesis, I highlight the data set at hand, and I hit enter. And I find out that the standard deviation is 10,692.79. That's pretty awesome. That was way easier than working this big, scary looking formula up here. But I don't really know what it means. Okay. And so I'm going to walk you through a little process here that might help you understand it a little bit better. And once you understand it a little bit better, you develop a better sense of if you're doing the math right and if you're on the right track. I call that your sniff checker, kind of like when you smell milk and know if you should drink it or not. With math, it's helpful to be able to kind of look at your work as you're doing it and be like, ooh, something's off here. That stinks. Anyway, so I'm going to erase that and I'm going to show you this sort of table format of solving for standard deviation. And to me, when I was learning it, this really helped me better understand it. So again, here we have this kind of really intimidating looking formula with Greek letters and all sorts of stuff. So the little s means sample standard deviation, and it equals the square root of, this means the sum, okay? That big Greek scary looking letter means sum of x, or sometimes you'll see it as xi, minus x with a little line over it, and you'll hear that said x bar squared over the little n minus 1, okay? So x, or sometimes, like I said, you'll see it as xi, means each data point in the set. So this would be x1, x2, x3, x4, x5, etc., down to x10, okay? X bar means the mean of the sample. So if we just took the average of this sample, and then n means the number of data points in the set. So in this case, it would be 10. I can find that just by highlighting it and looking down here and seeing that my count is 10. All right. So let me just show you how to work this out. And then hopefully this will make it clear what standard deviation really is. So to find x bar, I'm just going to use the average function in Excel, equals average, and then highlight all the numbers, and it will give me the average. And like I said before, n is just the number or the count. And so I can use a count function, or in this case, I'm just going to put 10 because we already counted 10. So let me go ahead and I'm going to just copy x bar, or the average or mean, and I'm going to paste it as a value. So it's the same in each one. And then this line is xi, so the value of x minus the mean. And we'll see as we do this that some values of x are greater than the mean, and some values of x are smaller than the mean. And so we're getting to the heart of what I first learned, which was that standard deviation has something to do with variability. And what it really means is how far, so once we find the average, how far are these data points dispersed or spread out around the average, okay? So now that I have my value of xi minus x bar, I'm going to square it. So I can just do equals, click on that cell, Shift 6, which is a little up caret, is what they use for the exponent in Excel, and square. So that's saying square cell C2. And you see I'm getting like these big huge numbers here. So this is xi, or the value, minus x bar, the mean, squared. Okay. And then this, remember, this Greek letter means we're going to take the sum of x minus x bar. So that's a sigma, a capital sigma. Okay. So here I'm going to say the sum of all the x minus x bar squareds. And look at that's a huge number, right? So now we can kind of do our formula. We know that it is the square root of this number, sum of x minus x bar squared, so this number right here, divided by n over 1. So I can just tell Excel this equals the square root of the gargantuan sum of x I minus x bar squared divided by n, which we figured out right here, minus 1. Oh, and look, it comes out to the exact same number we got when we used the formula of stdev.s. Okay. So, all right. So cool. I showed you this weird table. And are we any closer to understanding what standard deviation means? And I think maybe a little bit. So let me talk through it just a little bit more, and then hopefully that will be helpful to you. If it's not, don't be afraid to hit me up down in the comments, and I'll try to explain it or even make another video if needed. So we have each value of x in a certain data set, and then we're going to find the mean or the average of the data set. And then we're going to find the difference between each value of x and the mean. So how much less or greater than the mean each of these values are. So this is greater than the mean by 1854, greater by 8963. This one's less by 10,005, etc. Then we're going to square that information, take the sum of it, and then find the square root of all of that divided by the number. So what this is really doing, if you think about it, is just telling us how variable or how spread out our data is. Now we can look at it and say, okay, so the mean is 35,372. That's the average cost of a car in this sample. And the standard deviation is 10,692.79. We won't get into the empirical rule, but in essence, we know that it would be very normal for our data to be plus or minus 1 standard deviation. Okay. Something like 2/3 of all data points usually fall within plus or minus 1 standard deviation. So we would expect 2/3 of the values of our cars to be between 35,372 minus 10,692. So about 24,000 something, and plus 10,692. So about 45, almost 46,000. So all standard deviation is this measure of how variable our data set is. The more spread out our data set is, the larger our standard deviation will be. The less spread out it is, the smaller our standard deviation will be. And that helps us understand the data set as a whole, and how, like I said, how dispersed it is, how spread out the numbers are. So I hope that helps understand a little bit of what standard deviation is. Like I said, in real life, do I ever do this? No, I just use the function equals stdev.s for a sample, .p for a population. But when I'm trying to understand what it is, doing it in a table like this helps me understand that this is all about the dispersion, or how spread out the data set is around the mean. So, hey, if you have questions, just like I said, put them down in the comment section. If this was valuable to you, please like it, share it. All these things help this information go out to more people. And I hope you have a great day.